So one of the ways that a linear relationship that we're looking at with these variables is different than the type of linear equation you might see in, say, a college algebra course is that these are values that are representing things that are happening in the real world. They have an application around them. So because of that, we want to be able to interpret what the slope and the y-intercept are actually telling us. And we want these interpretations to be specific. We don't just want to say, as x increases, y increases. Well, what is x? What is y? How much is it increasing? Okay, we want to be able to answer all of those questions. So when we go to interpret our slope and our y-intercept, because we're representing real world things, I have kind of some general forms that you can follow. You can adapt these a little bit if you have a better way to word them, but in general, when we interpret the slope, we can go ahead and say that if the explanatory variable increases by 1, the response variable will increase or decrease depending on if the slope is positive or negative, an average of the value of the slope. So now in this explanation, I have italicized explanatory variable, response variable, increase, decrease, and the slope. All of these italicized, so they're the slanted words, should be changed according to your linear relationship and the variables that you're looking at. You should never write, well, if the explanatory variable increases by 1. Don't write that. If the hours studied increases by 1, if the temperature increases by 1, if the age increases by 1, and so on and so on. So we want to make sure that we are very specific. Okay? And then for the y-intercept says if the explanatory variable is 0, then the average of the response variable is equal to the y-intercept value. So again, those italicized words that I just underlined, those are going to be different for each situation. So let's look at an example. So I found a relationship between the age of a Toyota Corolla and how much people are asking for the price to sell the vehicle is modeled by y hat equals negative 624.1x plus 11,593. Whew, that's a lot of numbers. So we're going to interpret the slope and the y-intercept of this relationship. So I'm going to do the slope first. So remember, the slope is always the number next to the x. So in this case, that is negative 624.1. So the interpretation of the slope would be if so our explanatory variable. So the explanatory variable is going to be the age of the vehicle. So if the age of the vehicle increases by 1 year, then the response variable. So the response variable is the asking price. How much are they asking for someone to buy it for? Then the asking price of the vehicle and then we're going to look at our slope for this. So is it increasing or decreasing? Well, our slope is negative, so that means that it is decreasing an average of $624.10. And this is money, so our unit on this is dollars. So we want to make sure we include the dollar sign on there. So that is how you would interpret the slope in this situation. And then the Y-intercept. So the Y-intercept is the number that is all by itself. So that's 11,593. And the interpretation for this one would be if the age of the vehicle is 0, then the average asking price is $11,593. So if the age of the vehicle is 0, so if you have a brand new car, then on average, the dealers are asking $11,593 for these Toyota Corollas. So here's one example of how we can interpret the slope and the Y-intercept. So let's look at another example. So here we have the relationship between the temperature outside and the number of cans of soda sold at a convenience store. And we found that that is modeled by y hat equals 16.4x minus 621.8. So interpret the slope and the y-intercept of this relationship. So the slope, again, that's the number that is next to the x. So the slope is going to be 16.4. So the interpretation for that would be if the temperature outside, because that's our explanatory variable, increases by 1 degree, then the number of cans sold increases because it's a positive slope, an average of 16.4 cans. Or the average number of cans sold increases by 16.4 cans. Okay, so I just kind of rearranged it a little bit. But in general, we're saying if the temperature goes up by 1 degree, then you're going to sell 16.4 more cans of soda on average. Okay, that's what this slope is telling us. The y-intercept is negative, because it's a minus sign, so you have to keep that minus with it, 621.8. So for this one, if the temperature outside is 0 degrees, then you would sell an average of negative 621.8 cans of soda. Now this interpretation, it is not possible to sell a negative amount of cans of soda. So in reality, in the real world, which remember these are real world problems, if it's 0 degrees outside, then you didn't sell any soda. No one came in and bought a cold soda when it's 0 degrees outside. They're cold enough. Okay, so when we're doing these y-intercepts, if you have a negative y-intercept, one of the things you should ask yourself when you go to do that interpretation is, well, does it make sense to be negative? Okay, there are some situations where you could have a negative value, and that's totally fine. But in this case, it doesn't make sense to sell negative cans of soda. Okay, that means people are bringing sodas back, and people don't do that. So the reality would be you didn't sell any soda this day. It was too cold out. So here are two examples of how we can kind of follow this general form, maybe tweaking it a tiny bit, to interpret what the slope and the y-intercept are telling us in the real world. This is what's actually happening with these things, with these Toyotas and with these cans of soda. So there you go.